quick housekeeping things here before we get back into working on this. You might want to be grabbing your calculators if you haven't already while I'm talking through these things. Um, First, congratulations, speech people. I think we received a notice on Monday, just fantastic results. Lots of people going on to either state, state at this point. Good morning. So, I mean, that's fantastic. I think there were a record number this year, so good job. The other thing that I wanted to mention was the MCAs, because yesterday I knew I was running out of time. And on the back board, right in the middle, in blue, I put what's happening next Monday and Tuesday with the MCAs. So during this hour, juniors will stay right here. We will test in this room on your Chromebooks. Make sure your Chromebooks are fully charged. One of the rules the MCAs has is that you can't have a cord attached to your Chromebook, so it's got to be fully charged when you come in here. Everybody else is going to have a study hall in room 264, and I think that might be Mr. Janan's room right down the hallway here, a couple of rooms. So only the juniors take the MCA math test. The rest of you, I know the other classes had a lot of questions about, are we going to have to make up the tests that we missed because of COVID and all that kind of stuff? So far the answer has been no, but just hang in there because the rules seem to change every year. I know you take your science MCA when you're actually in the course that requires it. English takes care of the other two, the reading and the writing, and those are usually in different years. But math is junior year. That's where we catch everybody. And this year especially, they wanted to make sure everybody knows that if you really want to for the MCAs, you can hear the voice read the problem to you if you have just a basic pair of headphones. The school does not have enough for everybody that's a junior to have those basic headphones because they can't have Bluetooth capability or anything like that. And I know everybody has fancy headphones, but these would be like your parents' headphones. All it does is plug in and you hear what's going on the computer. And the only time I can really think of where that would probably be an advantage was I had a really lower level reading student once who came to the word inequality and had to raise his hand because he's like, I don't know what this says. Is this inequity? And I did pronounce it for him. So otherwise, I don't know that you'd need that anyway. But just so you know, you can. Basic headphones for the MCA. All right, questions about the MCAs that are going to take place Monday and Tuesday. Non-juniors, 2 days of study hall. If it does take you, you do get as much time as absolutely necessary to finish the MCAs. So if you don't finish in those 2 days, counseling will pull you out of your math class and let you finish on the third day. Yeah. Yes. Are we going to have notes? No, I decided there's just too many juniors in pre-calculus to try and move forward, and it's too much stress on them too, so it's best if we just take a couple of days and say nothing.
It's just that math hour, that study hall.
It is, just math, yeah, because we're taking care of all the testing in the math classrooms. Yeah, Grant. I don't think I'm going to have you check in. I think you can go right there if you want to. But if you stop in here because it's Monday, you have the weekend to forget. If you just want to poke your head in and see that it's 264 and then go down there, you could do that too. But I did already give Mr. Janan the list of people that he should expect so he can take attendance down there. All right, so let's warm those calculators up because we absolutely know that we need that. Talking about the law of sines and our ambiguous situation. And in this hour, we had like one more thing to punch in on this problem, and I ran out of time. Yep, there it is right there. So it's a good thing I stored all of that so that I can just pull it back up on my calculator. We had found the measure of angle B sub 2 and C sub 2, and we just needed to figure out what little side length C sub 2 was. And we set up a proportion for that. And of course, we would cross multiply to solve proportions. And then we'd go ahead and divide by the sine of 30 degrees. And we pop it in the calculator. So like I said, I'm happy I saved the exact measurement in there as E as I went through this. So I'll go ahead and punch that in. We've got 6 sine of E. And we need to divide that by the sine of 30 degrees. Oh, and I forgot to hit divide first. Let me try it again. There's my E divided by sine of 30. That's better. 1.189. And then especially, since we ran out of time, let's just do the inventory. Go back and see what was the measure of A, measure of B, well actually A sub 2, B sub 2, and C sub 2. To keep those separated from the ones that we already did for the first triangle yesterday. Way back at the beginning, the measure of angle A stayed constant. That was 30 degrees. B sub 2, that one changed. That one we had at 144.315 degrees. And the measure of angle C sub 2 was 5.685. And little a stayed consistent at 6, and little b at 7. And then we just found the side length for C sub 2. So again, these problems, you're showing a lot of math. There's a lot of steps. That's a lot of points on the test, and I always feel horrible because in a class this size, there's at least one person that's only going to do one of the triangles. And they're just going to totally forget about the other one, and I can't give you the points for that one when you do that. So it's so important that you know there are 2 triangles beforehand, and you find those 2 triangles when you see these problems, which usually come like this. We don't get the split page telling us, hey, this is going to have 2 triangles. We have no drawing, we have nothing to go by, and we have to do this from start to finish. So solve triangle ABC if A is 43.1, lowercase a is 186.2, and lowercase b is 248.6. So the first thing we do is realize, well, this is side, side, and angle. This is the ambiguous case. I have to figure out how many triangles I'm going to have. So I'll put my little A in the corner, just like we did yesterday. Lowercase a across from it, opposite angle, or opposite side from the angle that we're at. And then I need to put little b over here as my adjacent. Get my other little labels on there. And I have to know the height of the triangle. If I know the height of the triangle, then I can figure out how many triangles I'm going to have for this situation. So again, that's going to be sine of 43.1 degrees equals h over 248.6. So 248.6 sine of 43.1 degrees will give us our height. So I'll have to punch that monster in. $169.862. So there's a lot of steps in these problems. I would say this is the most important step right here, knowing how many triangles you're going to get. Well, 186.2 is definitely longer than 169.862, so we're guaranteed one triangle. But now think about swinging this side over like a pendulum to figure out, is it going to hit inside, or is it too long, and is it going to hit outside? Will it hit again and form another triangle? This one's a 2 triangle. Yep. Because it's shorter than side B. Well, let's get started. We know there's a lot to do. So our first triangle like so. And we know we can use the law of sines because it's definitely side-side angle. And I realize the pair that I have that's opposite is the pair I have to start with. So sine of 43.1 degrees over 186.2 equals. Don't have a choice about what I have to find first. The only other information I have is that 248.6, which is across from angle B. And now I have 3 numbers out of 4 positions in my proportion, so I can solve for that one. So we'll cross multiply. Divide by 186.2. Now here's a really important step. You have to show me that you understand that you're going to have to use the inverse sine to get the angle. So as you get the feeling now, you want to start skipping a few algebra steps. This is not a step that you can skip here. You have to show me that that's how you're going to find the measure of angle B, is by using the inverse sine on that big mess that I have right there. All right, so I need to punch in 248.6 sine of 43.1. Yep. Divide that by 186.2. And take the inverse sine of all of it. 65.819 degrees. Knowing I have lots of math left here, I got to store this. So I am going to go ahead and override this since we're finally done with that problem from yesterday. I'm just going to put it in B because it's the measure of angle B. All right, sitting in there waiting for us for what we need to do next. We have 2 out of the 3 angles. Well, we can certainly find the other one. Every triangle is 180 degrees. So if we take 180 minus the 2 that we have, which would be the 43.1, and our little 65.819 degrees, we'll be able to find the measure of angle C. So I'll need 180 minus 43.1 minus my B. And there's C, 71.081 degrees, which I know I'm going to need if I can find lowercase c. So I'll put my little code for my calculator key there and store that in C. And go after it. So we go back to the pair that we absolutely know that the book gave us, which was sine of 43.1 degrees over 186.2. We know we have to figure out little c, so we don't have a choice for what goes above that. That has to be the sine of our angle C, which again we write down as 71.081, but knowing that we're going to use those perfect decimals that we have stored in the calculator. So C sine of 43.1 degrees equals 186.2 sine of 71.081 degrees. And then we would divide by the sine of 43.1 degrees. And that will give us our little c. So I think back about where everything's stored, and I can do 186.2 sine of c. And then I need to divide that by the sine of 43.1 degrees. Well, that's not what I must have punched in. Oh, again? Thank you. You know what? I think maybe I'm pushing it and it's not taking it. Maybe I'm not pushing it hard enough. 186.2 sine of c divided by, that's better, 257.790. There we go. All right, let's inventory that triangle. Measure of angle A. Given to us from the beginning, 43.1 degrees. Measure of angle B. Found that one up here. 65.819 degrees. Measure of angle C. Just found that one. And that one was 71.081 degrees. Little a was given to us. That was 186.2. Little b was given to us, and that was 248.6. And we just found c. So we have them all. As again, lots of points on a problem like this. And when you think about the amount of time this problem takes, you know there can only be one of these on the test. It's not like we could say, oh, let's give them two. One of them only has one triangle and one has two. It takes too much time. Now, every once in a while, somebody gets stuck at this spot because they're like, I know there's something over here that's supposed to help me with the other triangle, but just can't remember what it is. And the way to get yourself out of that, if you get stuck, is make the drawing of the other triangle, which would be that little sliver triangle. And then try to connect it up with something that we already know, which would be this triangle over here. The way to get that little sliver of the triangle is by taking this side and using it as a pendulum. And what that does is it gives us an isosceles triangle. So we already have a piece of information to start this one, and it's all about what our B angle was when we first went through this problem. So our B angle ended up being 65.819. Which means we can find the measure of angle B sub 2 since that forms a straight line, which is 180 degrees. But let me separate this. So my math for triangle number 2 here doesn't start running into triangle number 1. All right, the measure of angle B sub 2 is 180 degrees minus 65.819 degrees. Again, I'm glad I went ahead and stored that as angle B. There it is, 114.181 degrees. And I'm going to store that one. I'm going to put that in D. So I can use that as I go through the next calculations. Because now I have angle A sub 2 and angle B sub 2, and I can find angle C sub 2, because every triangle has 180 degrees. So 180 minus 43.1 minus the angle we just found. (22.719 degrees). And even though we know the next step is where we're going to be able to find the last of the information, I'm going to go ahead and store it in E, because like I told you yesterday, it's definitely better to be safe than sorry. Store everything in case something goes wrong. Then it'll be there in perfect form, and you won't have to punch it all in again. Because we know little a, we know little b, little a sub 2 and little b sub 2, we need little c sub 2. So go back to the one that they gave us, which was 43.1 and 186.2. And because we want to find little c, we've got to use our big C on the top. We have a proportion, we cross multiply. And then we divide. All right, so I stored that one in E, 186.2 sine alpha E. And I need to divide that by the sine of 43.1. 105.247. For little c sub 2. Now, let's inventory that one. Our A was still 43.1. B sub 2, 114.181. C sub 2 was 105 point, whoops, not big C sub 2, not little c sub 2. Angle C sub 2 was 22.719 degrees. A sub 2 was still 186.2. B sub 2 was still 248.6. But little c sub 2, side length c sub 2, was 105.247. On a 50-point test, this could easily be 8 points, 8 points for a problem like that. I mean, there's a lot going on there. And yes, there was a lot of repetition. You know, there's a lot of use of sign on that one, but still good problems. A lot of really good math. Whew. Well, we're done with those. But now we need to look at the applications, the word problems. It's pretty rare when we say, hey, the amount of math it's going to take for the word problem is less than what we're going to do when we have a non-word problem. Example 4 is locating a fire. Forest Ranger Chris Johnson at Ranger Station A, so right here, sights a fire in a direction that is 32 degrees east of north. Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line that's 48 degrees west of north. Find the distance from each ranger station to the fire. Well, the first thing I think is, well, I can find these two angles right here, because if we're using a compass, we're talking about 90 degrees, and we can take 90 degrees minus 32 and figure out what the measure of angle A is here. So we've got 58 degrees for angle A. Same type of thinking for the measure of angle B over there. Ta-da. So now we know what those are. So now we need to think, would this be a problem that I can use the law of sines for? And it is, because we have actually angle side angle right here. We've got that information, so we can use that. And what they want to know is, from both of these stations, how much are we talking about? So let's find a pair here that has measurements, which means we need to know what the measure of angle C is, because we'll need those opposite sides in order to set up our proportion. So 180 degrees minus 58 degrees minus 42 degrees. Well, 58 and 42 adds to 100. And then we've got 180 minus 100, so we have 80 degrees up here. So we can find all of this good information. We just have to plug it in. Sine of 80 degrees over 10 equals, and then it's up to you which one you want to go after first. I'm going to do mine alphabetically. I'll do the sine of 58 degrees over little a, cross multiply, and again, really important that you have what would give us an exact value before you grab that and put it into the calculator. So 10 sine of 58 divided by the sine of 80 degrees. .611. And this time we did get units of measurement. This was in miles, so we'll label that one miles. And then we'll go after B. So we'll start again with sine of 80 degrees over 10. But to go after B, we need the angle opposite, the side opposite each other here. So sine of 42 degrees over little b, cross multiply again. So 10 sine of 42 degrees divided by sine of 80 degrees. .795 miles. Now I write too big, but we really should write a sentence because we've got two different answers here for A and B. So, find the distance from each ranger station to the fire. The distance to the fire from station A is 8.611 miles, and from station B, 6.795 miles. Just a nice little summary so that somebody that's looking at this problem will know we found them both. You know, they're over there, and then they could backtrack and find all the math. The distance to the fire from station A is 86.11 miles, and from station B, 6.795 miles, and I wrote the word 2 down twice. There we've got it. That wasn't so bad for a word problem. A lot less work than the one we just did before that, right? So let's take a look at example 5. Finding the height of a pole. A road slopes 10 degrees above the horizontal, and a vertical telephone pole stands beside the road. The angle of elevation of the sun is 62 degrees, and the pole casts a 14.5-foot shadow downhill along the road. Find the height of the telephone pole. Yeah, Tristan.
So back on example 4, when you're trying to find the distance, what you do, like for station A, what you do B,
They wanted to know the distance from each station to the fire. So A would give them, oh, I see what you mean, because they're opposites. I need to change my A and B. Thank you, Tristan. I had to look at my drawing again. From station A would be the B. I reversed those two. B is 8.611 miles, and to station A is 6.795. Thank you. I reversed those two. Gotta go back to the drawing where opposite sides have the lowercase letters. All right. Example 5, finding the height of this pole. Now, the part of this problem that messes with everything is that the road slopes. So this would normally, we'd think of, you know, on a flat surface, be a 90-degree angle. But it's not going to be 90 degrees. It's going to be 100 degrees because the road was sloping. Well, then I start thinking, well, what else? What did they give me other information? Because that's not enough to use law of sines. Well, the pole casts a 14.5-foot shadow. So that's going to go right here. And now I have to use some of the other information they gave me so that I can figure out another angle. Because I can only use this if I know angle, angle, side, angle, or side, side, angle. And I realized this 62 degrees, that's important, because these two are vertical angles. That angle would also be 62 degrees. Way back in geometry, called the bow tie angles. You've got vertical angles here that are going to be the same. And if that's the case, hey, I can figure out what angle C is up here, because this was 90 degrees. If I take 90 degrees minus 62 degrees, I'd be able to get it. It's 28 degrees. So now I can find what they want to know, which is going to be find the height of the telephone pole. So they want little a. And I realized, well, I can't do that unless I know what the measure of angle A is, because I have to use the law of sines here. So far we have 128. Let me write them both down, though, because we had 100. And then we had 28. And that leaves us with a little 52-degree angle, right? Boy, I can't fit that in here. I'm going to have to use an arrow. That's 52 degrees in there. Well, we've got to use the 14.5. We have to use the 28 degrees because that's the set of opposite sides that we have here. And we're going to have to use the sine of 52 degrees because that one is opposite our little a, which is the height that we want to know. And there's our proportion. So we'll cross multiply. And divide by the sine of 28 degrees. And we'll punch that in and see what we get. It all in there. 24.338. Label. It's a word problem. There's got to be one up there. Feet. So that was even less work than the problem before with the ranger station. So now, what threw me was, I don't know if you saw that message that came up. It says I have to restart my computer or it's all going to crash in 30 minutes. And I already restarted it twice this morning because it said it needed updates. So I got to start this again, which this is where I wanted to stop with you today anyway. You'll only have 2 problems that you'll have to watch on the video for tomorrow. And obviously you won't be able to finish 5.5 day 2 until we finish those, unless you're feeling like really super comfortable with law of sines. So maybe that's the case. So definitely 5.5 day 1 should be done. But if you want to hang on until tomorrow to do the rest of this for the day 2, totally acceptable. That's really frustrating. I got here early because I knew they were doing updates today. I guess 2 restarts aren't enough. It needs a 3rd one.